G'day, I'm Red Nectar and welcome to this Cisco ACI Flash Lab. When a packet reaches an ACI leaf switch, does the leaf switch learn both the layer 2 MAC information and the layer 3 IP information, or does the switch only learn the IP address if the packet has to be routed? If you'd like to know the answers to these questions and how I figured them out, then hang around and keep watching. My need to know the answer to these questions came about because I noticed something in this slide found in an old 2018 Cisco presentation. It was the words, "On ingress, the leaf learns the MAC and IP address of the arriving frame," that caught my attention. I thought, that's true for ARP frames, but what about IP packets that are addressed to the target MAC address rather than the default gateway's MAC? So to test if ACI leaf switches learn layer 3 information from IP packets not sent to the leaf layer 2 MAC address, I set up this lab with two IP hosts on the same subnet on the same switch. Now, one of the challenges I had to overcome was to stop my host from sending any ARP requests, because I know that ACI leaf switches do learn both MAC and IP addresses from ARP requests, as you'll see in a future Flash Lab. And I think this characteristic of ACI leaf switches is probably the reason why there is confusion about exactly what information ACI gleans from IP packets too. So to prevent host 1 here from sending any ARP requests, I've configured a static ARP request for the MAC address of host 2. So when I conduct the first test of attempting to ping host 2 from host 1, an IP packet will be sent directly to host 2's MAC address. And since I have the bridge domain configured to send layer 2 unknown unicasts to the hardware proxy, the IP packet should be sent to the proxy, which I've shown here as 10.2.176.64. And I have a monitor PC that's monitoring the links between the leaves and the spine. So we'll see that packet turn up there as well. Other relevant configuration items are shown here, and at some stage you'll see me use this segment ID of the VRF to help limit the results I see when I query the COOP database on the spine. Once I've completed the first observation, I'll go to host 2 and attempt to host 1. And I've also added a static ARP entry on host 2 so that the behavior should be much the same as the first test, only the first packet should be sent directly to host 1 rather than the spine proxy. And once the leaf has learned that MAC address, the replies from host 1 should come back to host 2. But we may actually see some of those go back to the spine proxy before that MAC address is actually learned here on the leaf. But at the end of the day, we'll have two hosts communicating, and we'll be able to examine the host tables on the leaves and the COOP database to see if any layer 3 information was learned. This is my lab environment thanks to housley.com.au. Here I have host 1. I've just completed the static ARP entry, ready to do the ping to host 2. I have a Wireshark capture running in the background to capture all the packets that we're going to see there. Here's host 2. Also with its static ARP entry and with Wireshark running in the background to capture anything that we see there. On the same PC here, my remote desktop, I have a SSH session to the APIC, and let's do a show tenant 07. That's the tenant we're working with. Have a look at the endpoints there. There's nothing there. Let's use that VRF ID to query the COOP database and see what's there. We expect to see the default gateway IP address of that of these hosts. There they are, and that's all we should see in the COOP database. And just for the sake of completeness, I'll show you that these. We'll have a look at the MAC address table as well, if I can find. There it is. And so that's our show MAC address table. It should show us anything that's either of these two hosts should get decaught with that. Now, just before we kick off with this and before I hit enter on this one, I would see the ping here. And remember, I've got the monitor PC over here. And so I'll just show you that we've got that ready to go. And Here we are with the ping. It's about to go. Drum roll, please. Here we go. Ping goes out, and there goes the ping, and nothing gets there. No, nothing turned up here. But let's have a look here and run those commands again. Have a look, see if we see some endpoints, and what do we see? Nothing. No endpoints yet. However, let's have a look at the MAC address table then. We should see a MAC address pretty soon. So there it is. Let's go and have a look at these endpoints again. So it's taken a little while to learn, but sure enough, here it is. Here's the MAC address that we expected to see. And if we query the COOP database, then we should see that MAC address there as well. Now, here's the $64,000 question. Is there any IP information? Here's the MAC ending in .50, but no IP address. The only IP is the default gateway IP address. Now, remember this first packet that went to the Leaf? Leaf should have sent that to the proxy, and sure enough, here it is. It's been captured, and if we look at the destination IP of that packet, we can see it came from Leaf 1. This is the IP address of Leaf 1. And 10.2.176.64 is the IP address of the spine proxy for layer 2. Awesome. Now, let's do the return packet. Here is server 2, ready to go. I'll send 2 ping packets because it may take a little while to learn that MAC address. So here we go. There goes the ping packets. I can see that they went out there. Let's see, he got request and request. So the first one didn't make a reply. So that means that we should see one more back over here. Sure enough, because what happened was the ping got to the first server, host number 1, and host number 1 sent the reply back, but the switch hadn't quite registered that second MAC address yet, so it sent it off to the spine, and so we do see it up here at the spine again. And back here, the second ping packet got through, we got the reply, and most importantly, what do we see in our databases? So let's start with show tenant to tenant 07 endpoints. We see just 2 MAC addresses, no IP addresses. We'll have a look at the COOP database as well, and we should see both MAC addresses there, but no IP addresses. And let's see, there's our 50 MAC address. Here's our 7 Charlie MAC address, and our original default gateway IP address is still there, as we'd expect. And just to finish off, let's have a look at the MAC address table again, and it should have 2 MAC addresses in there. Oh, and one more thing, I guess I should have a look at our app server EPG and see if we've got some things in the operational tab, and sure enough, the endpoint's there, the MAC's there, there's no IP address as you'd expect. In conclusion then, I have demonstrated that ACI leaves and the COOP database only learn layer 2 MAC address information from IP packets. In short, layer 2 behaves like you'd expect it to, except that frames addressed to the MAC addresses unknown to the leaf are sent to the layer 2 Anycast VTEP address instead of being flooded. But as you can see, there's an option to flood, and we'll explore that in a later Flash Lab. Join me in the next Flash Lab. Well, I'll expand the topology to include 2 leaf switches and introduce an endpoint that's in a different subnet but the same EPG. Don't forget, if you think this video will help anybody else, hit the like button, subscribe, and all those things. Better still, tell your ACI colleagues directly via a link to this site. And before I wrap up, a big thank you to housley.com.au for allowing me to use their ACI lab. If you'd like me or one of my colleagues to conduct your ACI training, use the link I'll leave in the notes below. Until next time, this is Red Nectar saying bye for now.